Over the past 3 weeks or so, physicists and Russian anime girls and Bilibili live streamers have all been talking about one thing: room temperature superconductivity. They've all been trying to achieve this ultimate quest in physics that people have been trying for the past 100 years. It started when three obscure Korean scientists that nobody had ever heard of before got into a tiff with each other, and one leaked their collaborative paper without the permission of the others. Then the other two also released the second paper, and these two papers combined claim that after 30 years of work, these Korean scientists have managed to make a material that shows room temperature superconductivity properties. Immediately, Chinese, Korean, and Russian scientists, as well as anonymous Twitter accounts and institutional teams and scientists all across the globe, started to attempt to replicate this experiment, live streaming every day whatever they were doing. They had to first create this material called LK99 and then test it for superconductivity. Soon, others started jumping in, and pretty much the entire physics community was tuned into this for over 3 weeks with very confusing and conflicting results and opinions. And now it appears that the story might be over, but also maybe not. So what is really happening? Do we have room temperature superconductivity now, and are our lives going to change? Why is superconductivity even such a big deal? Let's have a look. So here's the basics of what we need to know first to understand this whole story. What is superconductivity and why is it so exciting to scientists? Every material that conducts electricity around us in our homes and offices are conductors with resistance and voltage. If the voltage is zero, the resistance is zero. The concept of superconductivity is barely 100 years old and was first discovered in just 1911 and can be explained not by regular physics but with quantum mechanics. And superconductive materials are often created by mixing conductive metals. Superconductivity is a property where below a critical temperature, a material loses all of its electrical resistance. This means that while electricity flows through the material, there will be no loss. Theoretically, and in fact even practically, electric current passed through a loop of a superconductive material will flow indefinitely without a source of power or without applying any voltage. The temperatures needed to achieve superconductivity today are typically so low that they're measured in Kelvin. They're somewhere between 75 to 100 Kelvin, or about minus 183 to about minus 200 degrees Celsius. The longest superconductivity experiment that has been ongoing has a persisting flow of electricity for the past 28 years, since 1995. It's a gravimeter in Belgium that has been causing a superconductive sphere to levitate over a magnet. Superconductive materials typically do not exhibit conduction or magnetic properties at room temperature, but when a material is cooled and transitions from its room temperature through its critical state and enters into its superconducting state, it also becomes magnetic. In fact, it expels its entire magnetic field, and because of that, it starts to repel other magnets nearby. This phenomenon is called the Meissner effect. The Meissner effect is often confused for diamagnetism, which is a completely separate property. Unlike ion filings that get attracted to a magnet, diamagnetic materials tend to be of the opposite charge and naturally repel magnetic fields and magnets. This can cause confusion during superconductivity tests because in experiments, superconductivity is typically shown by achieving the levitation of the superconducting material over or below a magnet below the critical temperature through the Meissner effect and not diamagnetism. So what did the Korean authors publish? Scientists from Korea previously had been studying superconductivity starting from the late 90s, and in 1999 they manufactured a polycrystalline material called LK99, Lee Kim 99, the year of discovery. It is a modified form of lead apatite containing trace amounts of copper, and Lee Kim are the surnames of the scientists who were involved. These scientists are the authors of the new papers, and they claim that This material LK99 is a room temperature superconductor with a critical temperature of 400 Kelvin or 127 degrees Celsius and ambient pressure. This critical temperature means that when this material LK99 is below 127 degrees Celsius, it is a superconductor, which means even at room temperature, it's a superconductor at ambient pressure. That's what the Korean scientists claim. These scientists are now with a private company called Quantum Energy Research Center in Korea, and with a couple of other collaborators, they jointly published this work. Rather, they uploaded this work as preprints. In February of this year, a YouTube video was posted by Quantum Energy that showed a thin layer of LK99 levitating over a magnet. The authors then filed for a trademark for the material in April. On 22nd of July, 2 preprints were uploaded to archive by various authors from the original paper who had seemingly had a disagreement. Some authors also alleged that the original paper lacked in necessary details and data, and the next day the findings were submitted to the journal APL Materials for peer review. As soon as the papers were uploaded online and came to attention, physicists recognized that LK99 was a material that was relatively easy to synthesize because its recipe was easy to understand, approximately. Immediately, both institutional scientists as well as independent home-based scientists started attempting to replicate the material and the scientists' findings. An anonymous Russian plant biologist scientist called Iris Alexandra with an anime girl avatar started to replicate the recipe for LK99 at home. This person is credited as having performed the first diamagnetic replication of the material, if not superconductive. 2 teams from China then claimed to have replicated LK99 superconductivity. A team from India claimed it. Everybody posted their findings in the form of videos and preprints. Multiple individuals since then have gone on to attempt the replication of the materials and its superconductivity. And in fact, experiments are still ongoing. This story is not over yet. But many experts are still skeptical about the replication attempts and the original materials, and they believe that this phenomenon could more likely be explained by diamagnetism than the Meissner effect. Many of the levitating LK99 replicates seem to be exhibiting something similar to moderate diamagnetism as opposed to the Meissner effect. Some of those who have actually replicated the material and the effect are also not entirely clear of what is happening or what they have. The authors of the original paper then provided a clearer video to New York Times, but that was still met with the same skepticism of diamagnetism. An academic body called the Korean Society of Superconductivity and Cryogenics constituted an expert committee who then went on to invalidate the original material that the Korean scientists posted, saying that neither the video nor the papers seemed to confirm superconductivity. And they said that if quantum energy could provide an original sample of LK99, this committee will also conduct a review and replication effort. But Quantum Energy, meanwhile, has shut down its website after it came to light that they had falsely named research institutions and companies as their partners on the site. So what is happening with all of this? Is this confirmation of room temperature superconductivity or just superconductivity? Not really. Any scientific phenomenon can be confirmed experimentally only if it can be replicated and is also peer-reviewed. So while there are multiple independent replication attempts, there are currently none that confirm that there has been superconductivity, and there has been no peer review just yet. All of the original studies, including the original LK99 papers, were uploaded to the archive preprint server. Replication attempts have also been uploaded to the same server. And for good reason, because it turns out that we might not entirely be sure if anybody was successful. In fact, many believe that it was more diamagnetism than anything else. What is the consensus? Among Western scientists, after a whole bunch of replication attempts worldwide, people have come to the conclusion that now this was not superconductivity. They think that instead it was a combination of diamagnetism and some ferromagnetism. It looks like one reason the researchers suspected this could be superconductivity and zero resistance was a measurement error. They were using instruments at room temperature and with very low currents. The measurements taken with these conditions could make distinguishing between superconductivity and conductivity of copper difficult. On the other hand, many Russian and Korean scientists still don't think that the story is over. The Russian anime plant biologist, who seemingly has access to knowledge from the Soviet era about public superconductivity experiments from the time, seems to agree that this is not over too, although she also is a little bit skeptical. Russians have indeed been working on superconductors for a while, as have Koreans. But it looks like, at least for the immediate future, the excitement has subsided a bit. There are still more replication attempts and peer review is still ongoing and pending. So over the next few weeks, we might still be hearing more about this. But unless the results are utterly world-changing, literally, we are stuck with figuring out how to focus on reducing emissions.